model is called the virus model, which simulates the transmission and perpetuation of a virus in a human population. So here, you can see a number of sliders: the people, infectiousness, chance recovery, and duration. This represents the number of people in the simulation. The percent infectiousness is the one that determines how great the chance is that virus transmission will occur when an infected person and susceptible person occupy the same patch. The percent chance recovery controls the likelihood that an infection will end in recovery or immunity. And the duration determines the percent of an average lifespan that an infected person goes through before the infection ends. When you run the model, you can see here the percent infected, percent immune, and the number of years. And below that is a graph that represents the whole simulation. So to run a model, we set the people at 200, percent infectiousness at 60%, chance recovery at 40%, and 50 weeks. So just click the setup button and go. This will run the simulation. So here, we set up the infectiousness percent at 60% and the chance recovery is at 40%. So as you can see, to run the model, there is an increase and decrease, or increase and decrease of both the sick people, the immune, and the healthy people over the years. So this means that people reproduce immunity and healthy people, while there's also an decrease in the number of sick people. So running this model for about 22 years, so there is a stable graph for the percentage of sick, immune, and healthy people over the years. Okay, let's take for example, there is an 80% infectiousness and 0% chance recovery. So let us see what will happen to the simulation. So as you can see, in the simulation, at this percentage, at 1.9 years, there's already 0 healthy or immune people, and there is a 100% infection caused by viruses. So this means that if there is no chance recovery and there is a high rate of infectiousness, at 1.9 years, there will be no healthy or immune people. And when you go on further, as you can see, at 2.4 years, there will be no more people, or the population will die. So as we go on, in 4.2 years, the population density has gone to 0. Another scenario is we have a small percentage of infectiousness, which is 5%, and 80% chance recovery. So let's see the simulation. Initially, we have 5% infected people. So over the years, for about 5 years, there is still a low percent of infected people. And percent immune is about 0.1% only, because there is a high percentage of healthy people. So this will be shown in the graph here that there is a higher percentage of healthy people, and there is a slow spread of the virus, which is only about 5%. So that simulates the different scenarios for if you change the slider for infectiousness, chance recovery.